Welcome to Master Mathematics in Minutes. Today's topic is the geometric series. And we'll cover a couple examples on how to apply the geometric series formula. And we will conclude the topic with a summary. And finally, be kind and subscribe for more videos. So what is a geometric series? A geometric series is the sum of the numbers in the geometric progression. So with a as the first term, a times r as the second term, and the last term is a times r to the power of n minus 1. And we'll add all these terms together, and we'll denote that as Sn, because we're summing across the first n terms. And that is a geometric series. So we saw in the previous video that Sn is equals to a into 1 minus r to the power of n divided by 1 minus r, and r cannot be equals to 1. And if we're summing across an infinite number of terms, with S infinity is equals to a divided by 1 minus r, provided that the absolute value of r is below 1. So we'll have a look at a couple of examples on how to apply these two formulas. In the first example, we're given the following geometric progression: 2, 4, 8, 16, 32, and so on. And we're asked to find the sum of all of these terms. So, with a as equals to 2, being the first term, and with the common ratio as r is equals to 2, because 2 times 2 is 4, 4 times 2 is 8, and so on. And we have a total number of 7 terms in this progression. And so we have Sn is equals to a into 1 minus r to the power of n divided by 1 minus r. And because we are summing across 7 terms, we will replace n with 7, and it becomes S7. And a is equals to 2 from above, and with 1 minus r is equals to 2 from above, and n is equals to 7 from above as well, divided by 1 minus r, which is 2 from above. And simplifying that with S7 is equals to 254. In the second example, we're asked to find the sum of all the terms in this geometric progression. So with 128, 64, 32, and so on. So the first term, a, is equals to 128 in this case. And the common ratio r is equals to 0.5, because 128 by 0.5 is 64, 64 times 0.5 is 32, and so on. And with a total number of 8 terms. And so, Sn again is equals to a into 1 minus r to the power of n divided by 1 minus r. And we'll substitute n as equals to 8, because we are summing across the first 8 terms. And a is 128 from above. 1 minus r becomes 1 minus 0.5 from above. N is equals to 8, again from above. And 1 minus r becomes 1 minus 0.5 from above as well. And simplifying that with S8 is equals to 255. In the third example, we're given the following geometric progression: 9, 81, 729, and so on. And we're asked to find the sum of just the first 3 terms. And because of that, we can ignore everything behind the third term. So with a as equals to 9, being the first term, the common ratio as equals to 9, because 9 times 9 is 81, 81 times 9 is 729. And because we're summing across the first 3 terms, we have n is equals to 3. So again, with Sn is equals to a into 1 minus r to the power of n divided by 1 minus r, n is now 3, because we're summing only the first 3 terms. A is 9 from above, and 1 minus r becomes 1 minus 9 from above, and raise that to the power of 3, because n is equals to 3 from above, And 1 minus r becomes 1 minus 9. Again, r is equals to 9 from above. And simplifying that with S3 is equals to 819. In the fourth example, we're given the following geometric progression: 100, 90, 81, and so on. And we're asked to find the sum of all of these terms. Notice that this geometric progression is incomplete. We're not given all of the terms, but we're only given the first 3 terms. So this is an infinite number of terms. So we have a as equals to 100 as the first term, and with the common ratio r as equals to 0.9, because 100 multiplied by 0.9 is 90, 90 multiplied by 0.9 is 81, and so on. And with n as converging to infinity, because we're summing across an infinite number of terms, and we have s infinity as equals to a over 1 minus r, and a is 100 from above, and with 1 minus r, which is 0.9 from above. And so simplifying that, we have 1000. And so, given an infinite number of terms in this geometric progression, we're able to calculate the sum across all of these terms, and that is equals to 1000. To summarize, a geometric series is the sum of the numbers in the geometric progression. So with first term as a, second term as a, r, third term as 8r squared, and so on, and we add all these terms together, and we'll denote that as Sn because we're summing across the first n terms. And that is a geometric series. And so we had 2 formulas for Sn. The first one is Sn is equals a into 1 minus r to the power of n divided by 1 minus r, provided that r is not equals to 1. And if we're summing across an infinite number of terms, with s infinity as equals a over 1 minus r, provided that the absolute value of r is below 1. Thank you very much for watching. This is Master Mathematics in Minutes.